Good morning and salam sejahtera. I'm Welzelin Anak Bisop from University Teknologi Mara, Malaysia, and today I would like to present my research on the growth response and nutritional status of eggplant Solanum melongena L planted in soil incorporated with oyster mushroom waste. First of all, is a brief introduction of my research. According to Amin MZ 2014, the current mushroom production is about 24 tons, while the demand for mushroom is twice the production, which is about 50 tons. And the increasing mushroom production will lead to the abundant waste in the field, while recycling it requires a high cost. However, leaving it abundantly in the field will cause pollution. This study highlights the reutilizations of waste after the mushroom harvest in an effective ways as a soil amendment. Mushroom waste consists of non-toxic material and nutrient which can be used as soil amendment and add fertilizer to the plant. Reutilizing mushroom waste is one of the cost-effective approach in waste management towards a zero waste industry. The objective of my research is to evaluate the growth and yield response of eggplant in a different ratios of oyster mushroom waste and to assess the nutritional status of soil and eggplant after the incorporations of oyster mushroom waste. Next, moving to the research methodology. The experiment was conducted at established field plot at UiTM Sarawak for about 4 to 8 months, and the material involved are eggplant variety ARBCBJ 105, and the experiment was conducted by using randomized complete block design with 4 treatments and replicated 4 times. The experiment consists of 4 treatments, which is T1 100% topsoil control, T2 90% topsoil and 10% oyster waste, T3 70% topsoil and 30% oyster waste, and lastly T4 50% of topsoil and 50% of oyster waste. As you can see, the figure on your right side is the treatment arrangement. Next, the oyster mushroom waste preparation. The mushroom variety used is Pleurotus pulmonaris. 200 grams of dolomite were added in 200 kilograms of oyster mushroom waste. The purpose of adding dolomite is to improve the pH. Then, it will be composed in the gunny sack for about 2 months. As for the soil moisture content, it was conducted by using gravimetric method by oven-dried basis, while a soil-water ratio method was used for soil pH determination. Next, in this slide shows the method and procedure used to determine the NPK in soil and NPK, Ca and Mg in plant. As for the growth parameter, the development performance observed were plant height, number of leaf, leaf greenness, and dry biomass accumulation. The yield parameter involved in this study are the fresh fruit yield weight and the fresh fruit length. Moving to the next part, results and discussion. In response with the first objective of my research, which is to evaluate the growth and yield response of eggplant in different ratios of oyster waste mushroom, in my study, T4 with 50% of topsoil and 50% of oyster waste mushroom has recorded to have the highest mean soil moisture, followed by T3, T2, and T1. And with this, I believe that it has to do with the soil aggregation, which it increased the soil porosity so that the root of the plant can penetrate well as it helps in water absorption, air movement, and water infiltration, which will result in high soil moisture content. Past study by ICNUR and Chiefdat 2016 reported that the one with oyster waste mushroom application will result in a better soil amelioration, which improve the soil structure. And I do believe with this statement, as in my study, the one with high oyster waste mushroom, which is in T4 and T3, has better soil pH. And I do believe it has influenced the soil structure as it contains more organic matter and eventually will increase the soil pH. Next is the results on the growth parameter, which is the plant height. Based on the graph in figure 4.3, T3 recorded to have the highest mean plant height with 69.52 cm, followed by T4, T2, and T1. The oyster waste mushroom contain organic matter which can directly provide nutrient required by the eggplant. Next, the number of leaf. Based on the graph, T3 showed to have more number of leaf, followed by T4, T2, and T1. The utilizations of oyster waste mushroom incorporated in soil has greatly influenced the growth response of the eggplant. Next, moving to the leaf greenness. The SPAT value in T4 showed to have the highest reading, followed by T3, T2, and T1. As stated by Flores et al. 2015, stated that the SPAT value in leaf are related to the nutrient availability, and I do strongly agree with this statement, where in my study, all eggplant that are planted in oyster waste mushroom application shows to have the higher reading of SPAT value. Next, the dry biomass accumulation. Based on the graph, T4 showed to have the higher dry biomass accumulation, followed by T3, T2, and T1. In this study showed that the plant that are grown in soil incorporated with mushroom waste proved to have the higher dry biomass accumulation as compared to the one grown in the soil alone. This is due to the higher nutrient uptake, which helps plant to grow better, bigger, and accumulate higher biomass. Overall, T3 shows to have the highest fresh fruit weight, with a total yield of harvested eggplant of 6 kilograms. Overall, T3 had the better yield characteristic as the measurement of all harvested fruit were longer than T2, T4, and T1. In response with my second objective, which related to the nutritional status of soil and eggplant after incorporations of oyster mushroom waste, here are the results of my soil nutritional status. As you can see in table 4.3, clearly stated that the nutrient availability in soil incorporated with oyster mushroom waste has higher NPK content, especially in T3 and T4, even after the plant absorption. Lastly, on the plant nutritional status. Since soil incorporated with oyster mushroom waste has high soil physical properties value as mentioned in the previous slide, this condition allows the plant to absorb more nutrient, thus having more nutrient availability as compared to the plant that are planted in the soil alone. Alright, next, as you can see from the figure, the difference of fruit characteristic between treatments. Okay, so T3 has better quality of fruits with good fruit characteristic where the fruit is larger, longer, and the color are darker, as well as the size are bigger as compared to the other treatment. While T1, the color is a little pale purple, shorter, and the size are smaller. And the picture on the right side shows the defect fruit. From the figure, there are many defect fruit in T1, where most of the fruit has color with white stripe purple, and the fruit tend to defect at very early age. Now, we have come into a conclusion. As a conclusion, it is clearly shown that overall in T3 and T4 are significantly higher than T2 and T1 in all the parameters observed. That is all from me. Thank you.